Hi, my name is Pawan, and today I will be presenting Problem-Oriented Segmentation and Retrieval, case study on tutoring conversations. This was joint work with Rose, Kenny, Omar, and Dora. Many open-ended conversations, such as tutoring lessons, revolve around predefined reference materials like problem worksheets. Effectively structuring lessons around these materials is both critical and challenging, however. Educators must allocate the right amount of time to different problems while addressing student needs. And many novices teaching large groups of students often run out of time, for example. Fortunately, we know that providing evidence-based insights on lesson structuring is a key step towards addressing this challenge. These insights provide educators with feedback on their teaching, tutoring platforms with feedback on training priorities, and curriculum developers with feedback on material design. Given these lessons can be very long and hard to parse, however, obtaining insights on lesson structures at scale is challenging in and of itself. To address this challenge, our work introduces a new task that draws from two typically distinct NLP tasks. One being discourse segmentation to identify segments in the conversations, the other being information retrieval or IR to retrieve the relevant reference material for each segment. And while each task has rich literature, studying them jointly reveals real-world challenges that existing works bypass. For example, most discourse segmentation methods assume that conversations have predictable structure, but education conversations greatly vary as teachers adapt their lessons to different needs. Meanwhile, while prior IR work has studied supporting natural language queries over conversations, the reverse task of using open-ended conversation segments as queries for retrieving reference materials has not received similar attention. To address this gap, we introduce Problem-Oriented Segmentation and Retrieval, or POSR, which we define as a task that jointly segments conversations and retrieves reference materials such as worksheet problems discussed in each segment. More concretely, given a transcript T of n lines and a corpus R of reference materials such as the worksheet problems colored here, the goal of POSR is to divide the transcript into segments and retrieve the problem discussed in each segment, which more concretely means assigning pairs of segment ID and problem ID to every line in the transcript. And as an example of what POSR can do, even though conversations I and J here discuss the same worksheet, POSR is able to show us that conversation I covers fewer problems than conversation J, but spends more time per problem. As a concrete case study, we also introduced the LessonLink dataset, the first dataset of real-world tutoring lessons featuring 3,500 segments spanning over 400 hours of instruction and linked to 116 SAT math problems. Notably, tutors have the freedom in structuring their lesson, and to prepare their students for the SAT, typically determine what to focus on based on their students' needs. Then, we define and evaluate a suite of segmentation retrieval and POSR methods on the LessonLink dataset. Specifically, we evaluate a series of segmentation methods, including top 10 and top 20 word segmentation, where we segment the test set using the top 10 and 20 words found in the segment boundaries of the trained set. We also evaluate existing approaches like TextTiling and topic and stage-based segmentation, which segment discourse by topics and stages. Lastly, we test zero-shot prompting long context LLMs like GPT-4 Turbo and the Claude variants. Then we evaluate several methods for IR as well, whether that be traditional IR methods like Jaccard similarity, TF-IDF, BM25, or ColBERT. We also zero-shot prompt LLMs to perform retrieval. Finally, for POSR, we evaluate zero-shot prompted LLMs that can now perform both segmentation and retrieval jointly. And with all these methods defined and evaluated, we find that POSR methods outperform independent segmentation and retrieval approaches and at lower costs. Specifically, we evaluate these independent segmentation and retrieval approaches, which combine the best independent segmentation method with each retrieval method. We then compare them to our joint POSR methods, and based on the new SRS or segmentation and retrieval score metric that we introduced in our paper, we find that POSR Opus and POSR GPT-4 are the best performing methods and score much higher compared to the combined independent approaches. Additionally, we compare the costs of these methods and find that POSR methods are much more cost effective. Specifically, POSR Opus and POSR GPT-4 cost $11 to $21 per 100 transcripts, while the best combined independent methods, Opus plus GPT-4 here, cost $54 per 100 transcripts. Overall, this demonstrates the importance of jointly modeling segmentation and retrieval for better accuracy and cost performance. In parallel, we also find that our POSR methods specifically segment better than most independent segmentation methods by a large margin. Similar to our previous finding, we discovered this by comparing how accurately the independent segmentation methods and our POSR methods perform segmentation. And based on segmentation metrics like window diff and PK, which we describe in our paper, we find that POSR methods segment better than independent segmentation methods by a large margin. Zooming in, we specifically see that POSR methods generally perform better than their independent LLM segmentation counterparts. This leads us to conclude that retrieval items can serve as additional context that enhance segmentation accuracy, reinforcing the importance of treating segmentation and retrieval jointly. To better understand the sources of error, we also investigate the difference in predicted versus actual number of segments that our set of methods here yield. Notably, we find that traditional segmentation methods severely oversegment as they are sensitive to lower-level topic shifts. Then we also use logos to examine the categories of bigrams found in falsely inserted boundaries versus true boundaries. We find that incorrect segments are inserted when the tutor introduces examples, alternative explanations, or prompts for participation, such as when the tutor prompts their student to explain how they approach a problem. All in all, our analysis signal areas for improvement in precise segmentation. Finally, POSR enables several downstream applications that provide insights into tutoring practices at scale, and we are very excited to illustrate two here. So imagine there's this one popular problem on the SAT math practice test. You may wonder, how are different tutors teaching and talking about this same problem? What POSR allows you to do is extract all the segments where different tutors are talking about the same problem, and with those segments extracted, we can then run a language analysis to say, compare how tutors who spend more time on the problem versus less time on the problem talk about it. For example, we ran a log odds analysis which revealed that for this popular SAT question, tutors who spend a longer time on the problem tend to offer explanations about the underlying math concepts such as conditional probability, which shows up as one of the top diagrams in this setting. Meanwhile, tutors who spend less time on the problem tend to stick to the language of the problem statement and immediately explain the answer, as shown by the most frequent diagrams in this setting, which mainly includes keywords from the problem. Another downstream application of POSR is, given the same set of long SAT math worksheets, you might wonder, how do different tutors talk? How do different tutors distribute time across different problems? With POSR, you would be able to plot the talk time distributions across different tutors and problems, such as the figure here where we see that some problems have very different talk times, while others have very similar talk times. With POSR, you can also visualize how tutors manage their time across different problems and lessons, such as the one in the right figure here. In summary, our work introduces the problem-oriented segmentation and retrieval, or POSR task, a task that jointly segments conversations and retrieves the problem discussed in each segment. We also contribute the LessonLink dataset as a concrete case study of POSR in education, and finally demonstrate the potential of POSR by showcasing downstream applications such as a language analysis comparing tutoring strategies. We hope our POSR task, dataset, and proposed methods pave the way for further research in joint segmentation and retrieval, with broad implications for educational technology, conversational analysis, and beyond. Thank you so much for listening, and please feel free to check out our paper and code for more information. Feel free to reach out to us if you have any questions as well. Thank you.